Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime podcast. On today's episode, got a lot of news. It's definitely a news-heavy episode here. Number one, we're going to talk about the new Stripe Climate Initiative. So they're offering businesses a chance to give back a percentage of their revenue to fight climate change. So pretty cool. We're going to talk about GE turning a profit for the first time since 2018. Vestas buying out MHI's stake to kind of run their own, or the entirety of their offshore segment. Some changes in Vaisala, and a very interesting Danish study on birds and wind turbine collisions. Secondly, in our engineering segment, we're going to chat a little bit about vibration. So vibration sensors and what that means for the industry and how this technology, can effectively keep wind turbines running longer. So Alan, let's start with Stripe Climate. So new initiative they're rolling out. Stripe has basically pledged $1 million to a couple of different charities or that they're investing in essentially. And they've invited other companies via their Stripe Climate tool to choose whatever percentage that they want. So if you're checking out with, company X can say, hey, 1% of your transaction to us is going to Stripe Climate, which will help fight climate change. So what are your thoughts as you hear about this for the first time?
I don't have a lot of so much opinion about it. It's just trying to put it all in perspective. And a lot of the green initiatives, I think, need to be taken with a grain of salt in terms of donations. There are a lot of worries in the world right now with obviously coronavirus being way up at the top and the lack of employment for a lot of people and other things of that sort. Housing, poverty, you name it. So donations for carbon sequestration, which is what it is. I mean, carbon capture technology and reusing carbon in different ways or burying it somehow are interesting technologies, but where does it rank? And I think this is one of the issues that the climate change organizations have had over the last 12 months is that if you look at the list of priorities, the top 10 in terms of what they rank as issues, climate change is not typically in the top 10. It's way down. And it goes to, I think, part of the issue, which is we have the ability to make really big, impactful changes to the amount of carbon dioxide that's in the air. Given enough time, humans have been pretty good at fixing large problems. We just need time to do that. And that's where little initiatives can turn into big initiatives. So I applaud them for making reasonable donations to organizations that are companies that are looking at carbon capture and carbon reduction techniques, carbon dioxide reduction techniques, burning less hydrocarbons, those sort of things. Those are all great. But in terms of the big picture right now, I'm not sure how that plays. So this is why a lot of those things a lot of these donation sites don't seem so active right now. Plus we're in the middle of a campaign in the United States, and who knows how that's going to turn out. But, I think there's just a grain of salt here.
Yeah, I kind of felt the same way. I think it's good. And obviously everyone has their own, places they want to donate money. Some people are super passionate about the climate or the planet. Yep. Other people, like I know at the grocery store, you can round up for St. Jude, which is an exceptional charity, right? Like there's lots of different places you can give your money. So, if they're adding a new option, great. I kind of side with you there that I think if I was going to round up or, give $1 here or there, I'd probably want it to go to something that's more social work rather than, climate change personally. Yeah. But again, that's just me. Everyone gets to pick and choose and it's your money and your donation. Right. But you're right. I think it's a good step in the right direction because I know Patagonia has been one of those companies that does the 1% for the environment. Right. I'm not super tuned into that charity, but Patagonia has always given back some of their profits to, because they really do kind of stand by their commitment to the planet. So anyway, good, interesting little technology. Yeah. I think you're right. There's lots of different places to put your money, but good job, Stripe, for going in the right direction. So GE, in other news, has turned its first quarterly profits. They made $5 million in quarter three, which $5 million is like a Kleenex, yeah. But that's a pretty big change from losing $98 million in Q3 last year. Yeah. So that's $3 million swing. So they said they've been cutting costs and improving their pricing and stuff like that, especially in their onshore sector. Yeah. So you're a big American industrial champion. So how does this make you feel? Warm and fuzzy?
I used to work for GE, right? So GE has been a really historically very powerful company in the United States, if not the world, just because of all the technology they bring to bear and the industrial might they would bring to bear and the engineering capability, which they've had for 100 plus years. So yeah, it's good that they're starting to settle out a little bit. I think the issue for GE and a lot of the wind turbine makers right now is how stable is this marketplace going to be over the next 6 to 12 months, and how much consolidation is there going to be, and how are you going to minimize cost impacts and still deliver, because the technology push is more towards larger wind turbines, and larger wind turbines take more investment, particularly upfront engineering investment. So you're always scared about the risk reward of, I'm going to put $100 million or plus into a new design, and I'm not sure if that marketplace is going to materialize like I think that it will. There's your risk, right? And one misstep in a sort of a GE situation right now can be significantly impactful later on. So they can't miss. So everything they're going to do from the next year or two is going to have almost guaranteed marketplace sales before they go do it. And unless they can guarantee it, you're going to see them push off on any sort of technology advancements, so to speak. They're going to go for the items that pay cash, and rightly so, because everybody's going to be in the same boat, which is cash, 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 cash. Make sure that we're productive and make sure that our income and receipts are greater than our outgoing receipts. and it makes you more efficient temporarily. It does, but these periods of time in human development slow down innovation typically, because there's not a lot of excess innovation, excess cash to go do, or just too much risk, downside risk to bet the company on. So good for GE. I think we need them around, hopefully for a lot longer. And if you're a stock investor in GE, then happy days. Has the stock really increased significantly, Dan? I've been kind of watching it on and off. It hasn't really jumped a lot. It's not at 50. It's below 10 still, I think, right?
Well, GE overall is at 742 as of this exact moment in time. Yeah. And of course, this is just the renewable energy sector, GE Renewable Energy, that's turned a profit. So as far as the overall health of the business, haven't done enough digging to really comment on there today. But yeah, I mean, that's at least a good turn in the right direction for that sector. Obviously, GE did just roll out that massive jet turbine engine that we chatted about, right? The world's biggest, just insane thrust, and that thing's impressive. So, I mean, the technology's still there. So hopefully there's continue to go in the right direction. But speaking of technology, so Vestas they've bought out Mitsubishi Heavy Industries from their partnership for offshore wind. So now Vestas will forge ahead as pretty much the sole entity there. Now MHI has bought out a 2.5% stake, and I think they get a board seat, so they're going to still sort of like be there with them. But Vestas is going it alone from this point. And one of the things that their CEO mentioned in a recent Wind Power Monthly article is that they want to scale up and sort of catch now, GE and Siemens Gamesa as far as the output of their biggest turbine. So Vestas right now is at 10 megawatts. Siemens Gamesa has the 14 megawatt, and GE just scaled up their 12 megawatt Haliade to 13 megawatts. So Vestas knows they need to catch up there. Of course, they still are the market leader. They have about, it looks like, as of 2018, 20% of the market today. Right. I don't know the exact number as of this moment, but that's about double. It's double GE and a little less than double of Siemens Gamesa's like 12-ish% market share. So what are your thoughts on this withdrawal from the partnership here?
Well, I think it was set up that way from the very beginning. And that's what my impression was, is that was never going to be a long-term partnership. It's just the way it was established and when it was established, it was more of, hey, we both have capabilities, and if we could merge these things together, we could then have more capability to grow offshore wind, which is what the play was. And Mitsubishi has huge capability. It's such a gigantic conglomerate of a company, and it has all kinds of divisions. Much similar, it's very similar to like a GE. They're involved in everything.
Yeah.
So having that on the other side of the world compared to European-based Vestas makes you got sort of two manufacturing operations going on simultaneously, and so it brings a lot of weight to bear, especially since a large part of the wind market is in China. You can play that marketplace a little bit. But at the end of the day, I think the tax accountants sat around and the lawyers sat around and said, hey, guys, we can be much more efficient as a single entity, probably, and consolidate it into one organization. And because you're right, I think you're right. Vestas is seeing that the GEs and the Siemens Gamesa's of the world are driving to larger and larger wind turbines. Vestas has got to be up in that marketplace, and because they have a larger market share, you don't want to lose out in the future marketplace. They have to go there, and this is a place where you don't really want to put, again, because the costs for larger wind turbines are so massive, you don't want to miss. You don't want to lose market share. So they're in this really funny pinch area where they've got to build larger wind turbines and retain their market position to keep ahead of everybody else. That involves cash, and you're not in a really great place to go get cash today. So consolidation would make sense, I think, and we'll see what happens in 6 months from now. Aren't you hoping? And doesn't it sound like they have a couple of things on the drawing board, some geared turbines that are set up, and that there's a
they sound like they've got something in the
cooking,
works,
right?
As far as their tech.
Yeah,
and I would guess that you don't really catch up in this position. You just try to leapfrog. So I would guess that they're probably whatever's on their drawing board is not 14 megawatts. It's got to be probably 15, 16,
20
or 17.
Come on,
right?
20.
Well, because if it takes 3 years to develop, 5 years, I don't know how long these things take to develop, but they've got to know, like, this is where we got to go. Like, we can't. Why would we develop 2020's turbine? Like Siemens Gamesa already did that. So if this is going to be a new rollout in 2024, for example, it's got to be bigger. It has to be.
So the rotor's got to get bigger, right? The blades have to get bigger. Everything has to get bigger. It has to get.
They'll just have one wind turbine. It'll block out
the sun.
Be met with tons of activists. Yeah, because it'll block out a large portion of the sun. Somewhere in Missouri, like, there's a town that just no longer gets to have daylight because Vestas just has one turbine, 185 megawatts, just gigantic.
Oh, that's
something Mr. Burns would build in The Simpsons. What they're gonna do? That's my nonsensical prediction, but no, I'm sure they're going to try to leapfrog. That's I think the sensible choice if the technology's there.
Oh yeah.
So, and of course, at some point, it's probably not going to be a hardware mechanical upgrade. Maybe it's just they're trying to squeeze little extra bits of juice out without, because there is going to be a point, right? We can't. I mean, how big can they get before it gets just?
I don't know.
Logistically ridiculous.
That's a really good question. We haven't gotten
question.
there yet, have we? And I've only seen bits and pieces because there's been a lot of conjecture of where's that boundary, right? How it's sort of like the discussion back in the 40s. Can we break the sound barrier, and how fast can we really go? We don't even know. Obviously, there's more technology, and breaking the sound barrier was a big deal back in the 40s. But we're going 8 times, 10 times that right now in terms of speed. We never would have guessed that in the 1950s or 60s. We never would have guessed that, but here we are. So who knows?
Yeah. Well, it seems like it's going to become asymptotic at some point, right? Like with skyscrapers, they keep outdoing each other, but it's not like someone's throwing 50 extra stories on the next biggest skyscraper. No. It seems like it's just become such an engineering nightmare to get that much higher. And the question is like, well, for what good? Like let's just make two towers, rather than one that's 8,000 feet in the air.
Right, so, which is the answer, right?
Because all the
at what point do you make it one big one or 2 medium-sized ones, and what's the cost trade-off?
Because there's plenty of room in the ocean. Yeah, like you don't need a gigantic thing where you could just like, look, let's just space them out. Like 15 megawatts is fine. I mean, that's probably a discussion that's, I'm sure, been had.
Oh yeah, I think it has.
Interesting to think about what's
because there's a lot of costs on like the cables that feed back to shore, and all those little bits you don't think about so much add up to a lot of costs. And then when you find that sweet spot, I'm sure there's a lot of computers with a lot of spreadsheets that are trying to calculate this and figure out where that sweet spot is based on what the price of the turbine is, right? And the turbine manufacturers are also doing those calculations and trying to figure out what they can get, what the pricing they can get for a turbine is, because they're doing the same calculations. So if there's a cash advantage to building a bigger turbine, and the operators are willing to pay it because you see the payoff is just less maintenance or whatever that could be, then the turbine manufacturers are definitely going to go larger, right? That everybody's looking at the same spreadsheets. They're going to get to roughly the same answers. It isn't like there's 100 people working on 100 spreadsheets are getting wildly varying answers. I don't think that's the case at all. I think they pretty well know where sweet spots are.
So moving on to Vaisala, their GLD 360 technology, their industry leading lightning detection, used to be 5 to 10 kilometers. Recently, it's been upgraded down to 2 to like 1.5 kilometers, and recently they've said that their 4.0, their software, will deliver 1 kilometer median location accuracy. So how big of a deal is this, you lightning nerd, you?
Well, accuracy is everything. It doesn't, 10 kilometers is, in America talk, is 6 miles. So 6 miles is a long ways, right? If you're up by 6 miles, right? If you're trying to look to see if lightning has struck your wind turbine somewhere, and you have data that's off by 6 miles, I would say that would be a problem. Even if you look at the data today, you'll if you look at wind turbine locations and lightning strike locations, you'll see like, they don't seem to be hitting the wind turbines, but they must be. Come on, I mean, they can't miss it by 100 yards. I doubt that's the case, right? So you just aggregate them all into on top of the wind turbines. You just immediately do that, because otherwise the data doesn't make any sense. So the interesting thing about this press release is it says it's all done by software. That's the fix, or the improvement is the software fix. Like, wow, okay. So what is a software fix? What are they doing on the software side? Are they taking into account geography and height of objects around there to better position where lightning is likely striking? Like if I have a radio tower out in the middle of Iowa, and that radio tower is a couple hundred feet up, I should be able to tell that most of the lightning strikes around that area are hitting that tower, and then I can adjust my software accordingly to correct it, right? So you should be able to get some data off that, those known fixed points, and then software being what it is, to correct the data and provide more accurate data, which is what everybody's looking for, and which customers are willing to pay for. So they aren't only doing it because customers are willing to pay for it for more accurate data, and rightly so. You do want more accurate data, so it's a good step into providing more lightning knowledge on all kinds of things, not just wind turbines, and buildings and houses and all kinds of features.
Yeah. So speaking of data, a new Danish research study that just came out shows that almost no birds, it's the headline here from reneweconomy.com, which is the Australian site, die in collisions with wind turbines. So basically, hundreds of thousands of cranes, and what's the other type of bird here? They of a pink-footed goose were tracked via radar in this study, and they found only in the first year 17 dead birds, and in the third year
about the same,
only 22. Yeah, so a fraction of the hundreds of thousands of back and forths, I guess they did as they were migrating. So what does this study mean to you,
I think it explains the obvious, which that birds are not flying into the turbine towers, nacelles, or blades. The birds that were found deceased on the ground didn't look like they actually had impacted the turbine, nor did they see any marks on the turbine. So that's a good indication there's not been a collision. That birds have eyeballs, and they can probably tell what to fly around. And the radar data, which I think is fascinating. If you have a chance to look at the article that provides a little image of the wind, where the wind turbines are,
we'll put it in the show
notes.
And
where the birds are going around. So birds are intelligent creatures, right? That's how they live as long as they do. So they're flying around the wind turbines, especially if if you've been around them a little bit as a bird, you fly around a lot of different areas, I'm sure, because it's not safe, it's whatever. So they're flying around the wind turbines, but the conclusion they make doesn't really jive with the data they gave. So the conclusion is, well, they're flying a lot of flights, but they're not. The birds are not running into them. That's not the failure mode here for the birds. The birds and bats in the United States in particular seem to be dying from the pressure changes. So if the birds and bats are flying around the back ends of the wind turbines, there's some pretty severe pressure changes that occur on the backside of these blades, and that those pressure changes basically take their little lungs and just implode them or explode them a little bit and cause a lot of tissue damage and explodes all their blood vessels, is what it sounds like, inside their lungs, and they just die. And that's a really gruesome way to describe it, but that's the impression I get, is that it's the pressure changes that are causing the most deaths. So it's not that they're flying and hitting them, it's they're getting too close to the blade. So as the creatures get bigger, and geese and cranes tend to be larger birds, they're probably a little more resilient to the little tiny creatures like bats, which are very fragile. If they get around it, they're going to have more trouble. And I think this is where that a couple of episodes ago we were talking about painting one of the blades black seemed to make a big difference on maybe just keeping the animals further away. That must be the kicker here, is that it's a proximity thing. And I think you run into that effect because you live in Washington, D.C., and I think the one thing about Washington, D.C. that always really throws you off is... Yeah,
I run into buildings all the time. Well, it's a nightmare.
You don't have perspective. Well, let me ask you this. Have you ever seen the Washington Monument on the mall and go, oh, it's not that far, and start walking towards it, and then an hour later you're still kind of walking towards it? Your sense of perspective is all off. And I think that will do it to most animals. Your depth perception, especially for things that are straight in front of you, is really, really poor. This is why baseball is such a hard game. Anything you're having to look at straight ahead and try to get depth perception on can be very difficult, especially if it's large. So it's not in perspective of anything else. It doesn't have anything else to reference it to. So I'm guessing that the black blade gives you that contrast where, like, okay, there it is over there, I don't want to get close to it, and therefore decreasing bird and bat deaths, which would make sense. So maybe it's just a depth perception, visibility thing that's playing into it, not so much that they're running into the wind turbines as much as that they need a little more perception, and we can give them that.
Yeah, well, and it's good to have studies like this because, again, like a lot of the advocates against wind power are probably just going from the heart, and they're like, look, we love animals, which we all love animals. Yeah. But they're like, this is harming the wildlife, where it's good just to have some data. We're like, look, we know you maybe feel that way, but the data doesn't support that. Like, more birds are probably getting eaten by foxes or falcons, than these winter. I mean,
it's true. Relatively speaking,
bird deaths in a year, 20 bird deaths in a year, like more are going to die from some predator.
Probably, yeah,
without a doubt. By snakes, any of it. So it just puts it in perspective. Like, I think that's reasonable if this is another low-level predator at best that's introduced to their environment. I mean, that's something they can cope with for the probably greater good of the planet.
Yeah, true.
All right, so in our engineering segment today, we're going to talk a little bit about vibration. So Alan, we're going to jump right into this, but vibration sensors on wind turbines are especially helpful for gearboxes. Obviously, as bearings start to wear out over time, just knowing that, hey, this is making a weird, like we all have, this is making a weird sound, in our, whether it's our microwave or our car or our refrigerator. That's a pretty, like, it's actually, when you really think about it, how many things in your life could you say that this is making a weird sound? Maybe we should check on it. Maybe I should call a mechanic or whatever. So it's actually, it's funny how common this is now that I think about it out loud right here on the air. But so obviously this technology is important for wind turbines, which need to just be running all the time without fail. So tell me a little bit about vibration sensor technology, because they use this a lot in your other area of expertise, which is the aerospace sector.
Sure. And in aerospace, we use vibration sensors quite a bit, particularly on the helicopters, because they're just shaking, rattling machines. And things break in a helicopter, they don't glide very well. So you want to have some early detection of mechanical failures. And one way you do that is you just sense the vibrations that are going on inside the helicopter. And if you see frequency changes or amplitude changes, something abnormal, they get squawked early and caught, and have maintenance crews go out and look. And in fact, some of those helicopter systems are very diagnostic in that they're predictive, that they can say that vibration is caused by that gearbox, or that vibration is caused by that piece of equipment. You need to go check on that pump because that pump's going bad. Now that is a really beneficial help, because it reduces the amount of time on the repair side, but also provides data back to the operator to catch it before it really goes bad. So it's a benefit on all sides. On the wind turbine side, you don't see it so much, and I think there's again, as we get larger and larger turbines, you're going to see more of these systems get put onto the turbines, because they're predictive in a sense. If you have a good baseline of what the vibration signature is for the turbine, as it changes over time, you can then start assigning vibration frequencies and vibration amplitudes, particular failures, and start applying that across your fleet so that you can have predictive failures. So you know that vibration, when it gets to that amplitude, is that pump. So if I have that same vibration, but it's at lower amplitude, maybe I need to send a technician out there to take a look at it before it fails. Right. And so it can be very, very predictive, and you can actually lower your overall operational costs by doing that. Now, the problem is that with data overload, right? And I think this is the real kicker to all of it, is that as you instrument, you have to have some way of processing. And the way that it has historically been done is that you put a person in front of a computer and you have them watch it, on some level watch it. So you start looking at patterns, frequency domain stuff, time domain patterns, and saying, yeah, okay, that is associated with this. And so you have a human in your control loop, and what you want to do is get the human out of the control loop and then let the computers do all the hard work for you and just tell you when you need to go out and take a look at it. So the reluctancy on the aircraft side, except on power plants, right? So the engines on aircraft have basically vibration monitors, and helicopters have a lot of vibration monitors. But like if I bought a little tiny airplane, I would not have any vibration monitors. So if I bought a single engine Cessna, for example, that's a piston powered airplane, internal combustion engine, there's really no vibration monitoring equipment on those things at all, because relative to the cost, and it doesn't make sense. Whereas if I'm flying in a Boeing 777, Airbus A320, I probably want to put some vibration sensors on there. So as the wind turbines go up in cost and expense, you're going to see more of the technology go in. But it also comes with knowing what equipment is on that turbine and what its characteristics and what it looks like in the vibration world, in the data sense of what it looks like when it's working and what it looks like when it's not working, and then have that stuck on a computer somewhere. So it's not easy. It's not easy.
Yeah, that's what's really interesting. This article by electronicdesign.com is really in depth, and they're just talking about all the different speeds. So like the gearbox has a low speed rotor shaft and a main bearing and higher speeds, and there's planetary gears. So just like with all this stuff, there's transfer of power from one gear to the next. Higher speed, lower speed. So they're all going to have their own unique whine.
Yes.
Different hertz level, and so, but that is really fascinating. You think about the best mechanics. They've been doing it long enough. They just like put their ear to the ground when you're running your car, and they're like, oh yeah, it's probably this. You're like, how do you know that? Where they just know, right? But obviously this is going to be too many low frequency unique signatures.
Well, it's
like you said, you need a lot of algorithms and
filtering,
and probably machine learning and AI.
Yeah.
And I'm just throwing out buzzwords right now.
No, that's exactly what it is. But it's exactly what it is, though. Like a mechanic
to just say,
so the mechanic likes to take what they usually do is to put a wrench to the engine block and then put their head against the wrench, what they are doing is transferring the vibrations from the engine to their head, right? So you can get a sense of frequency, you can get a sense of amplitude by doing that, and then their little computer, which is their brain, is telling them what operates at those frequencies that could be bad in that engine. That's how they know. That's how you detect if you got bad valves or lifters or things like that. You hear the clicking and things go on. So humans are very good at detecting variations in frequency and amplitude. That's just feeling it, but auditory hearing it is really sensitive in humans. And so you can immediately tell, like if you're flying in an airplane and you hear a pitch change on an engine, you ever notice how people start looking around a little bit? You are set up to monitor for changes. That's what you're set up for, because changes can mean danger, and that's how your brain sort of organizes itself. Steady state is good.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe, and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.